I have already shared my screen with you. Can you check your screen and can you tell me? So today we are going to discuss A level physics, AS level physics, A and AS level physics paper 1, past paper, May, June 2025. So I have shared the screen with you. Can you kindly check your screen? Can you tell me so that directly we can move to the question paper and we can discuss one by one. So today in this part, we will discuss all the questions from question number 1 to question number 40, and we will divide this one according to chapter wise. Right. So in part 1, we will discuss the foundation and kinematics. Without delaying, let us see question number 1. Which quantity is a vector quantity? The question is on the screen. Can you tell me your answer? So I have identified the answer. So pressure is not a vector quantity. Pressure is something different. I will tell you. Temperature is not a vector quantity. It is a scalar quantity. Weight is a vector quantity, and work is a scalar quantity, right? So now let me explain you the reason with explanation. Which quantity is a vector quantity? Weight is the vector quantity. Why? So a vector requires both magnitude and direction. Already you know that vector has magnitude as well as direction. So weight is the force of gravity acting downward direction. Pressure, temperature, and work are scalar quantity. So that is why your option C is the right answer here, right? So when this type of question comes, you have to identify which physical quantity has only magnitude, and if the physical quantity has only magnitude, then it will be a scalar quantity. And if the physical quantity has both magnitude and direction as well as direction, then that physical quantity is known as vector quantity, right? Now let us focus on question number 2. In question number 2, if you look very closely, this is from measurement chapter. 4 students A, B, C, D have completed an experiment to determine the acceleration of free fall, right? Acceleration of free fall, G. Right, already all of you know that G. Each student repeated the experiment 3 times, and the experiment 1, experiment 2, and experiment 3. So they repeated the experiment for 3 times. The determined value of G is the GR shown in the table, right? So then what we have to do, we have to find out which set of result has a high precision and low accuracy. So this is very important question, and in every year definitely you will be getting one question in physics, AS level physics, from this chapter, accuracy and precision, right? Can you guess your answer? Of course, I have already highlighted option D. So then can you explain me why? What may be the cause for option D, right? I want to show you the explanation. Question number 2, option D will be the answer, The reason is that precision is the closeness of repeated measurement, right? Precision means the result should be very closeness of the measurement to each other. Point to be noted. Closeness of the measurement, the closeness of the result to each other, because set D is tightly clustered. So that is why set D is more correct answer. Then accuracy is the closeness of the average value, which is nearly 10.13, to the true value, 9.81. So then set D values are both precise but not accurate, because in the question we have to say that high precision and low accuracy. So I hope you got the clear explanation, right? Now question number 3 is from error calculation, right? So error calculation is also one of the important point. The diameter of a ball is measured as its value and its error. So plus or minus 0.02 indicates the error. Okay, plus or minus. What is the absolute uncertainty in the volume of a ball, right? So the ball is spherical in nature, and what is the volume of a sphere? Can you write in the comment box? Yeah, so my explanation is here. So when you want to find out the volume, so if you know the radius, so then you can write 4 by 3 into pi r cube if r is given as the radius. Otherwise, if the diameter is given, then you can write volume is equal to 1 upon 6 pi dq, right? So then you know the error calculation rule. So delta V upon V, right? So delta V stands for error in means change in volume. I mean error in volume upon the real value, real volume, the true volume, which is equal to 3 times. Why 3 times? Because 3 is the power. Already I explained you when I taught you the chapter. So when you are writing the error calculation, so the coefficient 3 is due to the power 3, right? 3 times, because errors are always added, not subtracted, nothing. So here it is added 3 times. That is why we are writing 3 times delta D upon D, right? So after substituting all the values, we got the value is 0.87. I think, is it clear to all? If you have any doubt or any queries, can you please write in the comment box so that I can see your queries. So option B is the right answer here. Got the point? So error calculation is one of the important point as per the examination point of view. Is it clear to all? Right. Now, shall we move on to the next question? Now, question number 4 is from your vector chapter. The question comes from vector topic. Okay, can you see two vectors, vector x and vector y is shown in the picture, right? So when you see this vector, what is the direction of x plus y and x minus y? So you have to find out the resultant of x plus y and x minus y, point to be noted, right? So I have highlighted the answer. So x plus will be in this direction and x minus y will be in this direction. So then I have to give you the clarification, right? Now, so if I move, when I taught you vector chapter, I said that vector can be shifted, either linear shifting or parallel shifting, right? So when I taught you the chapter, I explained you when you are going for operation in vector, maybe addition or subtraction or multiplication. So according to our convenient, vector can be shifted, either linear shifting or parallel shifting. Okay, so if you see here, so this is your y vector, right? So can I shift this y vector in the same direction up to here? I can shift here, that is called a parallel shifting. Or according to the convenient x vector, I can shift linear shifting. Okay, so then when we shift, so the resultant will be in this direction. Okay, so x and y. Okay, let me extend your x up to here. Is it extended? Right. Can I extend y up to here? Is it extended? Let me extend perfectly. Yeah. Now x and y. So this is your x vector and this is your y vector. Okay, it is not accurate, but I can show you. So when you add two vectors, the resultant will be in this direction. Okay. So this is the direction of x plus y. It is not exact, but it is matching with option B, right? Now, when we are talking about x minus y, so when we are talking about x minus y, so the direction of y is in this direction, right? So when we are talking about minus y, so minus y can I take in this direction? Yes. So this is the direction of minus y. Then what will be the resultant? So this is the direction of resultant, right? So can it be x minus y? Yes. So it is matching somehow to this result, right? So therefore, in this question, you got a clear explanation: x plus y and x minus y in vector addition, right? So I have mentioned here, and I have used AI for the explanation. Sometimes AI may not be 100% accurate, so that is why I used here the real-time explanation for you. I hope it is clear to all. If you have any queries, can you please write in the comment box so that I can get your opinion, right? Now let us go to question number 5. So question number 5 is related to your projectile motion. A ball is projected vertically downward with one initial velocity 20 meter per second. So initial velocity is 20 meter per second, point to be noted. Air resistance is negligible, so we do not count air resistance. What is the displacement from its initial position after time is 1.5 second, right? So then we have to note down what are the datas are given here. Initial velocity u is given 20 meter per second, right? Then time duration is 1.5 second. Then we are asked displacement s which is equal to, you know, that first equation of motion, s is equal to ut plus half at square. We can apply this expression. Now let us see my solution here, right? Okay, so if we use the values and substitute here in this expression, s is equal to ut plus half at square, so then we can find the value nearly approximately 41 meter, so which is matching to our answer D, right? It is clear to all. Okay, so I don't want to waste your time, that is I'm keep on moving quickly. So anything, if you find in any doubt comes your mind, if you write, then I can stop and I can answer to your queries, right? Question number 6 is related to same motion. A surveyor's device emits pulse of light, right? The light reflects from a wall which is 150 meters apart, means 150 meters away, right? What is the total time taken for the pulse to travel from the device to the wall and then back to the device? To travel from device to the wall, again from wall to the device. It is very easy, means, you know, this distance, again this distance, twice the distance, right? So 4 options are there. Of course, option D is the answer, but let me show you my explanation. Question number 5, is it question number 5? Question number 6, where is my question number 6? Yes, it's here. You know, the total distance is 300 meter. Is it clear to all? Because the light will go from device to the wall, again from wall to the device, the total distance is twice the distance, 300 meter. And speed of the light, all of you know that, which is 3 into 10 to the power 8 meter per second. Then if you want time, already you know that speed, which is equal to distance upon time. Then if you want time, then distance divided by speed. So after dividing, can you use your calculator? Then your answer will be 1 microsecond. And generally, if it is 1, then we are writing 1.0. In physics, many times if you are writing any answer, if the answer is 5, then we have to write 5.0, right? So generally we write in this way, or 3 significant figure, right? So therefore, where is my question? Okay, so here the answer is 1.0. Is it clear to all? Let me show you once again my solution. Is it 1.0 microsecond? Yes. Okay, question number 4, 5, 6 is clear now. So let us move to question number 7. Now question number 7 is on the screen. Which of the equation of uniformly accelerated motion can be derived using only gradient of velocity time graph? Okay, if I want to show you velocity time graph, okay, so let us consider this is your velocity time, okay, and suppose this is the graph for velocity time, right? Consider this is your initial velocity and this is your final velocity, and I want to draw the graph. So the graph is already drawn, then I want to find out the gradation. Okay, suppose this is your time, velocity time graph. You know, the gradient of velocity time graph tells about acceleration. So then gradient, which is equal to acceleration, you know, this is your v, let me erase this one, v minus u, yeah, and this is your time. So then acceleration is v minus u upon t. So therefore at, which is equal to v minus u, then v, which is equal to u plus at. So this is the expression we can find using only what? Gradient, right? So then here your answer is v is equal to u plus at, that we can use to, that equation can be derived using only gradient of velocity time graph in this equation, right? Question number 8 tells that an object is projected horizontally from a table at time which is equal to 0, and the object falls in a uniform gravitational field. Air resistance is negligible. The graph PQRS are the velocity time graph. Then we have to identify which graph represent the horizontal and vertical components of the velocity of the object, right? Now, if you remember when I taught you projectile motion, so when we throw, so consider this is a table and we are throwing one object, right? So when you throw one object, the object will go downward because gravitational attraction. So time is 0. So when the object moves, there is no force on horizontal direction. So if there is no force, no acceleration. If no acceleration, no change in velocity, right? But in the downward direction, there is a force, gravitational force. Therefore, there is an acceleration, gravitational acceleration, which is known as acceleration due to gravity. That is why velocity will be keep on changing, velocity will increase. But in the case of horizontal direction, no change in velocity, velocity is constant. So if you see, then P can tell us the horizontal, no, it is not horizontal, it is vertical, because the velocity is continuously increasing. But Q, the velocity is constant and there is no change in velocity. So then option A is the right answer here. So Q stands for horizontal velocity and P stands for vertical velocity. Can you write your opinion and comment in the chat box? I want to see. Right. Now question number 9. What is always conserved in elastic collision? Point to be noted. What is always conserved in elastic? In elastic collision, we learned about collision, elastic collision, inelastic collision, and perfectly elastic collision. So then which one is conserved? So 4 options are there. So which option is the right answer? Right, this is your question number 9. Then I want to show you my explanation here. So by definition, elastic collision conserves total kinetic energy. Momentum is conserved in all collision. So total velocity, the vector sum, is not conserved quantity, right? So therefore, kinetic energy is conserved and total velocity is not conserved because it is a velocity, velocity is a vector quantity. So then according to the definition, so then can you tell me which one is the right answer here? Yeah, total kinetic energy is conserved but total velocity is not conserved. So option B is the right answer here. Now let us move to question number 10. So this is related to your Newton's laws of motion. Is it okay? Shall we move to question number 10? Right. A firework travels vertically upward in the air. Okay, it is projected vertically upward in the air. Gases are downwards from the firework. Several forces that acts on the firework and gases are shown in the figure. Can you see the figure? Thrust, air resistance, force, all these several forces. Now tell me which forces are the Newton's pair? Which forces are Newton's third law pair? Newton's third law pair of force, action and reaction. I think you got the clear answer. So option C, force on the gas and thrust. So these are the action and reaction. And if you want, I can show you my explanation here. According to Newton's third law, pair must be the same force, same types of force, equal and opposite, and act in different bodies. So the firework pushes the gas, that is the action, and the gas pushes the firework, that is reaction. So therefore, option C is your right answer here. Maybe you may be confused. If you want something explanation, more detailed explanation, you can write. I will definitely give you more explanation with some other examples. So we are discussing past paper. So this is the answer for this question, right? Shall I move to question number 11? Two blocks K and L slides toward each other along a horizontal frictionless surface. The diagram shown the momentum of two blocks just before they collide, right? So what we have to find out during the collision, let me show you the complete question. Yeah, during the collision, the blocks are in contact with each other for a time of 0.084 second, right? After the collision, the blocks separate and block per second. What is the magnitude of average force exerted on block L by K during the collision, right? So option C will be the right answer, but you need explanation. So let me explain you now. I want to show you my explanation. Okay, you can see the explanation, but I want to give you a little more clarification. If I talk about Newton's second law of motion, the rate of change of momentum is directly proportional to the applied force and takes place in the direction of the force. So according to Newton's second law of motion, the force is equal to the rate of change of momentum, or we can write yeah, same thing only. So impulse means force into time, which is equal to change in momentum. Okay, so how do you find change in momentum? Change in momentum, which is equal to final momentum minus initial momentum, right? Now let me show you my explanation here. So final momentum and initial momentum. So the final momentum is 0.12 and 0.12 as it is given in the question, and the initial momentum is minus 0.46. The minus sign I have taken for the change in direction, right? So because I want to show you the question paper once again. So because in the question, the L moves back, means in opposite direction. So if I take one as positive, then the other one I am using as negative, right? So where is my solution here, right? So then the change in momentum is 0.58 kg meter kilogram meter per second. So then if I want force, then according to Newton's second law of motion, or we can say impulse momentum theorem, so then we got the calculation approximately 6.9 Newton. So then do we have option here? Yeah, so 6.9. So option C is the right answer. Any queries you have, or you got clear explanation? So question number 11 is clear. Now let us move to question number 12, right? Leonardo da Vinci, which is scientist and a very good artist. All of you know about him. So Leonardo da Vinci proposed a flying machine that would work like a screw to lift the pilot into the air. The screw is rotated by the pilot, right? The machine and the pilot together have total mass is 100 provide to move vertically upward at a constant speed of 2.5 meter per second. So we want to calculate power. Okay. So think for a moment. Of course, I have shown you the answer. Then I'm going to show you my explanation. If you see my explanation, we know that power is the product of force and velocity. Okay. So first of all, we have to calculate the force, I mean gravitational force. So which is equal to mass times of acceleration due to gravity, and the mass is given 120 kilogram, and the acceleration due to gravity is 9.8, or we can take 10 also. So which is this one, 1177.2 Newton. Then when we calculate power, so then the answer is approximately 2949 watt. So then our answer option D is the answer here, right? So when we are going to calculate power, which is equal to force times of velocity, then we have to calculate force, which is equal to mg, then you multiply with velocity, then you will get power, right? Okay, moving to the next question. Question number 13. Which row describe a pair of force that comes in couple, right? Couple, the turning effect of force, right? So when two force equally and acting opposite to each other, not on the same line, the line of action should not be same. So that is called couple. So then already you know the answer. So I have mentioned here that should be in opposite direction and that should be equal in magnitude, right? And if you want to see my explanation, can you see the explanation here? So a couple consists of two parallel, equal and opposite forces that do not share a line of action. Point to be noted. Okay, they create a pure turning effect, which is called torque, a pure turning effect with no net translation force. Okay, translational force, translated motion, right? So this is the definition of couple. And according to this is very important topic. Every year we find one question from Turk and couple. Okay. Now moving to the next question. Question number 14 is on the screen, and this is from your one question. Yeah. A uniform cylinder of weight 25 Newton. 25.0 25 Newton is suspended from a Newton meter. Yes, spring balance, Newton meter, right? The cylinder is fully submerged in water. You can see the cylinder is fully submerged in water as shown in the figure. The reading on the Newton meter is 10 Newton. So its mass was how much? Its weight was 25 Newton, but when it is submerged, it is 10 Newton. Now let me see what we have to find out. The water replaced by a liquid with a density 10% greater than the density of the water. The water replaced by a liquid. So there is no water, liquid. Okay. So the water replaced by liquid, right? Greater than the density, 10% greater than the density of the water, the cylinder remains fully submerged. So what is the new reading on the Newton meter? 4 options are there. So of course option 8 will be the right answer. So if you know the explanation, you can write, or I'm moving to show my explanation here. If you look closely to my explanation, so as I have mentioned here, the upthrust, which is equal to weight minus apparent weight, the real weight minus apparent weight. So the real weight is 25 Newton and the apparent weight after immersing into the water is 10 Newton. Then the upthrust by the liquid is 15 Newton. Is it clear? Then upthrust is directly proportional to the density of the fluid. Already we discussed regarding this fluid mechanism. So the upthrust is directly proportional to the density of the fluid. So the new upthrust, because in the question it is told that since the density increased 10%, so therefore the new upthrust is becoming what? 1.1, because 10% increased means 100 plus 10% increase. That is why we want to multiply with 1.1. This is the shortcut technique. So then the new upthrust is 16.5 Newton, right? So then the new reading will be, new reading is always weight minus upthrust. So then 25 minus new upthrust, which is equal to 8.5 Newton. Is it clear to all? So then in the examination, you know that because you have to answer 40 questions and your time duration is 45 minutes, right? So then each question 1 minute approximately you can consider. So you have to be quick and you have to calculate very quickly, right? So then now let us move to question number 15. Question number 15 is on the screen. So question number 15 is principle of moment, principle of moment. Yeah. A student balance 30 centimeter ruler on a fulcrum set at 15 centimeter mark. So the scale and the fulcrum is kept at 15 centimeters, exactly 30 centimeter. Then it is exactly in the middle, which is at 15 centimeter mark. He then places 50 gram mass on 20 centimeter mark and 20 gram mass on 11 centimeter mark are shown in the picture. You can see are shown in the diagram. So then what mass should be placed at 7? Here we have to keep some mass. So what will be the mass of the object? What will be kept there? That mass we have to find out. Law of conservation, the law of principle of moment tells that the sum of the clockwise moment must be equal to the sum of anti-clockwise moment, right? Then how to find out the moment with force and distance, right? So then here, here the mark is 15. So then this distance is 4 centimeter and this is from here to here is it 8 centimeter. Okay, consider here mass is x or m you can take. So then 20 into 4 plus 8 into x, can we write here 20 into 4 plus 8x, which is your anti-clockwise, then must be equal to clockwise. So 15 to 23. what will be the 15 to 23? 8. Yeah, correct. And then 8 into 50, which is equal to 8 into 50. Then you can find out the value of x, and I want to show you my explanation. This is your question number 15. Where is question number 15? Question number 15 is here. Yeah, 20 into 4 centimeter and m into 8 centimeter, which is equal to 50 into 80. Then after all calculation, we can get the value of m is 40 gram, right? And you got the answer. So here the answer is 40 gram. Now let us move to question number 16. A submarine is at a depth of 130 meter below the surface of the water, below the surface of the sea. Yeah. The pressure on the submarine due to the sea water is P, right? The submarine sinks to the depth 260 meter below the surface, right? That time it was 130. Now again it is going deeper. 260 meter. Assume that the density of seawater is constant. Yeah, that is the point. The density is constant. What is the difference between pressure on the submarine due to the seawater at two depths, right? So I taught you what will be the pressure. Okay, something rho gh. Can you remember? Okay, now let us see my answer. So then, as I told you, the pressure is equal to rho g h. Okay, so where rho stands, it is not P, it is rho. Rho stands for density, G stands for acceleration due to gravity, and H stands for height, right? So here density is same, acceleration due to gravity is same, only the height changes. Therefore, the pressure at 130 meter must be half of, or means the pressure at 260 meter must be twice of pressure of at 130 meter. So then the pressure difference is P. Is it clear? Right? So you have to use shortcut technique to find out the answer. So the pressure difference is P, which is your right answer. Okay, now let us move to question number 17 because we have to finish the multiple choice all the questions so quickly. Okay, now question number 17 is on the screen. An object is falling in a uniform gravitational field. Which two quantities are sufficient to calculate the change in gravitational potential energy? So 4 options are there. So which two quantity will be sufficient? Can you guess? Already I have shown you the answer. Next time I will not highlight the answer. You have to tell me. Gravitational potential depends upon mgh. Okay, so mg is the weight, right? So weight, and h is the change in displacement or height. Okay, so then you got the answer. So option D, weight and change in the height, I mean change in vertical displacement. So these are the two quantities is enough to calculate, right? So let us move on to the next question without any delay. Question number 18 is on the screen. The point X, Y, and Z are on a rough horizontal surface. Rough, it is not smooth. Then definitely friction will work there. A box P is pushed across the surface from X to Y, then from Y to Z. X to Y, then Y to Z. The distance from X to Y is 30 meter. 3 meter. The work done against the frictional force in moving the box from X to Y is 150 joule. The work done against the frictional force in moving the box from Y to Z is 200 joule. And an identical box Q is pushed in a straight line from X to Z, directly from X to Z, you can see here. So the magnitude of the frictional force between the box and the surface is constant. Then how much extra work is done against the frictional force moving P then Q, right? So we have to calculate here. It is a conservative force, non-conservative force. Already I taught you what is conservative force and non-conservative force. And the answer, of course, I have shown you here. Question number 18. I can see the answer on the screen, my explanation. Okay. So since you want quick answers, so I want to show you one by one quick answers. Yeah. Okay, Henry. So you want me to show you the answers one by one. So if you still find the doubt, you can ask me in the next class for clarification, because most of the answers you can find in my explanation, right? Okay, so then let me show you. So question number 18 is clear now. Now look at question number 19. The moment of a car of mass m increases from P1 to P2. What is the increase in kinetic energy of the car, right? So then I want to show you the answer here. Question number 19. So option A will be the right answer. Then my explanation is here. So all the students, those who are online here today joining, I have shared my screen in front of you. Yeah, you can quickly change the screen also if you wish. I have given the right. Okay, so then I am sharing one by one, and now you go through the solution. Then the doubt we will clarify in the next class. Question number 20, 19 is over. Then question number 20 is here, and the answer is also here. You can see, and those who are online watching on YouTube, you can pause the video and you can watch also, and you can see the solution, or you can write in the comment box. Definitely I will help you, and I will solve all the past papers last 5 years one by one, physics, chemistry and mathematics. That will definitely helpful for you. All paper 1, multiple choice, structured question, and even your analytical paper. Okay, paper 5 also. All the papers I will give you the fully solution with detailed explanation, right? Question number 20 is here. Question number 21. Is my screen is okay, or it is looking very small? Can you write to me? Otherwise, I can make it little bigger for you. Okay. Now the solution. This is from matter wave, the topic. Yeah. So question number 21 and the solution. Option D is the right answer. You can pause. Question number 22. So option C is the right answer, and the explanation is on the screen. When you want to get, you pause and you can find out solution. Now question number 23 is very important. Question number 23 is very important from Young's modules. So option D is the right answer, right? So 23, 24, 25, 26 is here on the screen. Shall we move? Okay. Now question number 22. So here option C will be the right answer, and the explanation is here. Question number 25. Simple harmonic motion, right? So here option C is the right answer, and the explanation is on the screen. And question number 26, right? Question number 27, 28, 29 and 30. So these are the question, right? And if I want to show you the solution, 27 option C is the right answer. 28 option B is the right answer. I have written with explanation. 29 option B is the right answer. Now 30 option D is the right answer. Okay, so is it okay? Now question number 31, option C, option A is the right answer, and this is from your wave chapter. Okay, now this is electricity and particle physics, last 10 questions. Question number 32, option C is the right answer. Let me show you the question once. So this is what your question paper, you can see, right? Question number 33, option D is the answer. 34, SP. Let me show you 34. Question number 34, you can see here. The diagram shows 6 identical resistors connected in the circuit. So you can 1, 2, 3, 4, 5, 6. Okay, so 6 identical resistors. Which branch of the circuit is the most power dissipated, right? So if you see this PQ, so here 2 resistors. So when the resistance increases, power cannot be more power cannot be dissipated. Okay, so then here PS is the less resistance, that is why most power can be dissipated, right? Okay, so then here the explanation is given here. You can find out, because P is equal to I square dissipated. Okay, now question number 35 and 36 is on the screen, and the explanation is here. Question number 35, option A. Question number 36, option B, right? Question number 37, option C is the right answer. Yeah, question number 37 and 38 is on the screen. 39 and 40 also. Then for question number 38, this is from your quantum physics. So option D is the answer. Then the explanation I have already given here. And same thing for question number 39 and for question number 40, right? So then if you have any question, if you want the solution of any question, you can write in the comment box. Definitely we will discuss in the next class for the same question, right? So thank you very much for joining the class. So in the next tomorrow in the morning, we will have more discussion on the theory class, right? Goodbye.